Welcome back, everyone. Today I want to review the topics of FOILing and factoring. To work up to those topics, I want to review the laws of exponents involving multiplication. I also want to review combining like terms and distributing. So let's start with this problem. I want to multiply x squared with x cubed. Well, all we have to do is we keep the base. Remember, this is the base and these are the exponents, and we just add the exponents. So we get x to the fifth. For the second problem, we're going to do exactly the same thing. Here I have three things being multiplied together. They all have the same base, so we're going to add the exponents. If you don't see an exponent, you can just put a 1 there. So this is 4 plus 3 plus 1. Which is x to the 8th. Okay, let's keep going. This is going to be x to the negative 1 plus 4 plus 7 plus a negative 3, which is x to the, well, this is 3 plus 7 plus negative 3. These 3's cancel. We get x to the 7th. Sometimes I put a line through my 7s. Here I didn't, but I can put a line here. The reason I do that is because sometimes it looks like a 1, or, and I don't want to get confused with my 7. Right, the next one is we're going to take 2x and multiply it with 4x cubed. This is a little more complicated, but all you have to do is multiply the numbers together and then worry about these x's. Again, you can put a 1 right here. If you don't see an exponent, it's assumed to be 1. So we take care of the numbers, and then we take care of these x's. So 2 times 4 is 8, and then we add these exponents. That's our answer. Let's try this problem. Again, we're going to repeat the same process. Multiply the numbers first. We have a 6 and a negative 3. That makes a negative 18. And then we worry about the x squared and the x to the 5th. 2 plus 5 is 7. This one's a little more tricky. This is saying I have negative 2x and I'm multiplying it 3 times. In other words, I have negative 2x times negative 2x times negative 2x. So I have 3 of these negative 2's. So if you take negative 2 and multiply it with negative 2, you get a positive 4. And then you take 4 and multiply it by a negative 2, you get negative 8. Then you have an x, x, and an x. And because none of them have an exponent, we can just put a 1 here. So we have 3 of these, so this is x cubed. Another way to do this is to distribute this 3 to the exponents. So what we're going to do, I'm going to do it right over here, so it gives you another way to solve this. Put a 1 above the negative 2 and above the x, and then send that 3 in to these numbers and multiply 1 by 3 and 1 by 3, and you'll get negative 2 cubed, because 1 times 3 is 3, and then x cubed, and negative 2 cubed is a negative 8. So you get the same thing. How about this problem? I'm going to work this 2 ways, and you can choose the way that you like the best. The first way is I'm actually going to write 2 of these 4x's because this is squared, and I'm going to write 3 of these because this is a cubed. So this is 4x times 4x times this negative 3x. And I put this parentheses around this negative 3x because I don't want to confuse it with subtraction. This is not 4x subtract 3x. We're multiplying it by a negative 3x. And then times 1/2 x times 1/2 x and times 1/2 x. And you can keep the parentheses if you want to. You don't have to though. Okay, we want to multiply all this together. Now we can multiply all the numbers together and then worry about the x's, or we can do it in pieces. So for example, we can multiply these two together first, which gives me 16x squared, because I have a 1 and a 1 here. And I can cross that out. And then maybe we'll pull this negative 3x down. And then we have a 1/2, a 1/2, and a 1/2. If you multiply all those together, you get a 1/8. Then an x to the 3, because I have 1, 2, 3 of them. All right, now let's continue. Cross this out, so maybe you can follow it a little bit better. Now what? Well, we take this 16 and multiply it by a -3 and divide by 8. You can do that in a calculator. I also noticed that this 8 goes into 16 2 times, so I can cross this out and put a 2 here. I'm left with 2 times -3, which is a -6. And so then that takes care of my numbers. And then I have x, well, this has a power of 1, so 2 plus 1, that's 3, plus 3, that gives me 6. So this is our answer. Okay, let's do it the other way that I showed you with the last problem. So I'm going to erase this and I'm going to put our answer to the side. So we should get the same answer with the second way I'm about to show you. So again, what we're going to do is we're going to put a 1 if we don't see an exponent. Put this in parentheses here, to the 1, to the 1, and this 1/2 to the 1, and this x to the 1. Distribute this 2 in, so this is 4 squared times x squared times -3. Well, this has a 1 and this is a 1 and this is 1, so we don't really have to worry about, if this was a different number, then we would need to distribute it. But this just becomes -3x. Then we have 1/2 cubed x cubed. So this is 16x squared, -3x, 1/8, x cubed. And we end up getting the same thing. Exactly what I got over here. I do want to mention something about this problem. What if, so let me clean this up a little bit. So I just want to focus on this last piece over here. What if instead of an x, I had an x squared? How would you send this in? Well, this would be, so just pretend like I'm not interested in this piece. I just want to know this piece. I've changed it a little bit. So this would be 1/2 cubed times x squared. So this 2 times 3. Because remember what I did? I put a 1 wherever there wasn't an exponent, but here I have a 2. So if I send this in, I get 1 times 3. And then if I send it in here, I get 2 times 3. So I'll have a 1/2 cubed times x to the 6th. Just want you to be careful with that. Again, you can write this out. So you'd have 1/2 x squared times 1/2 x squared times 1/2 x squared, because there's 3 of these. You see you get 2, 4, 6. So you get the 1/2 cubed, exactly what we said, and then we have x to the 6 because 2 plus 2 plus 2 is 6. All right, let's review combining like terms. When we have an expression like this, we look at things that just have a number. If we have more than one number, we're going to add them together. Then we look for things that have just an x. You can see that this has just an x and this has just an x. This one has no x's and this one has x squared. But if you just have x raised to the first power, which you don't have to put the 1 there, but they're both raised to the first power, what you do is you add the coefficients. If we're adding these two, we do 2 plus 3. So this simplifies to 4x squared plus 5x plus 7. Let's try another one. Here I have a lot more going on, but it's the same idea. You can start either with the x squares, the x's, or the numbers. It doesn't matter. But for example, here I have an x squared and here I have an x squared. So I'm going to add the numbers together and leave the x squared alone. So 3 plus a negative 2 is 1, so we have a 1x squared. And then we can cross that out. Now let's combine the things with just an x. So here I have a negative 5x and I have a 3x. So adding those together, I'll get a negative 2x. Because negative 5 plus 3 is negative 2. So we can cross those out. And then add the numbers together. 10 and 9 make 19. And usually we don't put a coefficient of 1 like that. We just drop it. And it's understood to have a coefficient of 1. Let's try another one. Maybe you should pause the video and see if you can combine like terms here. I have an x cubed and I have a 2x cubed. The coefficient in front of this x cubed is 1. So 2 plus 1 makes 3. So I have 3x cubed. Cross them out. I have a negative 7x squared and a 3x squared. 7, 6, 5, 4. This becomes a negative 4x squared. Remember, different signs, we subtract 3 from 7, and then take the sign of the bigger number here, which is 7. Okay, cross those out. We took care of them. Now I don't have anything else with an x other than this one, so we just pull it down. And the same thing with this negative 4. And this is as simplified as we can make this. Okay, now we're going to move on to distributing. Here I want to multiply 5 with x minus 3. What we do is we send this 5 into everything. So we get 5 times x plus 5 times a negative 3, which is 5x minus 15. Let's try another one. Here I have 2 times x squared minus 4x plus a half. Send this 2 into all of the terms. So this is 2 times x squared plus 2 times a negative 4x plus 2 times a half. So let's simplify this. This is 2x squared. 2 and a negative 4 make a negative 8. You can put plus a negative 8 or just minus 8. It's the same thing. And then 2 times a half. Well, 2 goes into 2 one time, so we get 1 times 1, which is just 1. 2 divided by 2 is 1. So that's another way you can think of it. We're done with that problem. Here's where you need to be careful. I see a lot of students make a mistake with this. We're taking a negative 1 and we're sending it in. We're going to have to change all of the signs. We have a negative 1 times x and a negative 1 times a negative 7. So this is a negative x, and then 1 times 7 is 7, and then we have a negative times a negative, which becomes positive. When you multiply by a negative 1, all the signs change, as you can see. Here's another example. Let's send in this negative 3 to everybody. I'm going to do this slow. So negative 3 times a negative 4x, and then negative 3 times 3. We're going to get, okay, this is reviewing what we did a little while ago. Multiply the numbers. Negative 3 times 2 is a negative 6. Then we have this x squared plus a negative times a negative is a positive. 3 times 4 is 12, and we have an x. And then a negative 3 times 3 is a negative 9. try this one. We're going to send this x into everything. So we get x times 2x plus x times a negative 7. So I have a 2, and then I have an x with a 1 and an x with a 1, so I get x squared. And this is a minus 7x. Let's try another one. Here we have a 4x. We're multiplying it by 5x squared minus a half times x plus 1. Send that 4x into everything. So 4x times 5x squared plus 4x times this negative 1/2 x plus 4x times 1. Here I'm going to multiply the numbers together. I get 4 times 5 is 20. This x has a power of 1, so 1 plus 2 is 3. Then I have 4, so I have a positive number times a negative, which will make this overall a negative. Then 4 divided by 2 is 2. And here I have x to the 1, x to the 1, so that makes x squared. And then this is just 4x. Another example. Send this negative 3x squared into everything. Okay, we have a negative exponent, so we need to be careful here. We also have a negative in the front. But I'm going to write all of this out. This is negative 3x squared times x to the negative 1 plus a negative 3x squared times 2x plus a negative 3x squared times a negative 7. Okay, the only coefficient I have here is a negative 3, so I'm going to bring it down. Then I have x squared times x to the negative 1, add these numbers, 2 plus negative 1 is a 1. Then I have a negative 3 times a positive 2, that's going to make a negative 6. This has an exponent of 1, so I get x cubed. Negative and negative make positive. 3 times 7 is 21, and then we have the x squared. All right, let's move on. Now we're going to focus on foiling. Now I want to remind you what FOIL means. It's first, outer, inner, last. First means I multiply the first term in both of the parentheses. Outer means I multiply the outermost terms in both of the parentheses. This one's all the way to the left and this one's all the way to the right. Inner means I multiply the two things that are closest to each other in the parentheses. So this 2 and this x, they're the closest. And then last means in both of these parentheses, I take the last thing and multiply them together. So let's follow all of those steps. So to multiply these two together, I start with first. That's this x times this x. So x times x, and here we've taken care of first. Then I'm going to do outer, which is this x and this 3. So that's x times 3. Then inner, 2 and x. We can cross that out. And then last, this 2 and this 3. Once you get good at this, you don't have to do it exactly in this order, as long as you have all 4 of these pieces. You could do maybe outer first, or you could do first and then last, however you want to do it, but you'll have 4 pieces. Okay, let's clean this up. So this is x times x, which makes x squared. We always put the coefficient in the front, so 3 times x plus 2 times x. 2 and 3 make 6. So now we have x squared, combine like terms, we get 5x, and then plus 6. Okay, let's put FOIL up here. Maybe you should pause the video and try to FOIL this. and see if you get the same thing I get. All right, I'm going to take care of the first thing, which is this x with this x. Outer, which is this x with this positive 4. Inner, which is this negative 7 with this x. And then last, which is this negative 7 with this 4. Okay, so I get x squared plus 4x minus 7x minus 28. Combine these two terms, so we're left with x squared minus 3x minus 28. 7 minus 4 is 3, and then we take the sign of the bigger number. Okay, let's FOIL this one. Again, maybe pause the video and see if you can FOIL it. I'm going to write out the answer. Let me write this as negative and a negative. And notice here that I don't have any like terms. Here I have a cubed, here I have a squared, this is the first power, and this is just a number. So I can't simplify it any further. Try to FOIL this one. So pause the video and see if you get the same answer I get. Okay, we're done with this one. Okay, things are starting to get a little more complicated. Here I have a lot of negatives, so we have to be very careful when we FOIL. You have a couple of options here. I'm going to go with the standard foiling. But what you could do is, you notice that you have an x with both of these. You could factor out an x. If you know how to do that, you could factor out the x and then multiply them by foiling and then multiply the x in. But I'm just going to do the standard foiling technique. So this is negative 3x cubed times 4x. That's the first ones. And the outer is a negative 3x cubed times a negative 1. So this one with this one takes care of outer. Then we have a negative 2x times a 4x for the inner. And then the last piece is a negative 2x times a negative 1. Let me make this a little bit smaller so I can put it on the screen. That takes care of last. Let's clean this up. Negative 3 and 4 make negative 12. Then we have x to the 4th. Negative and negative make a positive. 3x cubed. Then we have 2 times 4, that's 8. Then we have this negative here, so minus 8x squared for the x's. And then a negative 2x and a negative 1 make a positive 2x. And I can't combine any terms, so we're done with this problem. You'll see a lot of this when you deal with circles. You'll see something like x minus 2 squared. Now I'm going to tell you a common mistake I see all the time. And that is they'll send this 2 into everything here, and they'll say, oh, this is x squared minus 2 squared, which is x squared minus 4. This is a mistake. Do not do this, okay? No. It's going to be very similar to this, but there's actually going to be one more term. And let's see why it's a mistake. This is x minus 2 times x minus 2, because I have 2 of these. And now I FOIL it. So this is x times x, which is x squared. I have an x times a negative 2, so minus 2x. Then another minus 2x. And then a negative 2 times a negative 2. Simplify that, I get an x squared minus 4x plus 4. Do you see the difference here? I get x squared, I have a positive instead of this negative 4, and then I also have this negative 4x, which is not even written here. So you have to be very careful. Let's try another one. Y plus 5 squared. Again, do not send in the 2. That rule when I said sending in 2's was when we were multiplying. Here I have an addition sign, and in the last problem I had a subtraction sign. That rule where we distributed was only when we had multiplication signs. So here I'm going to write it out. This is y plus 5 times y plus 5. And then you FOIL it. You'll get y squared plus 5y plus 5y plus 25, which is y squared plus 10y plus 25. Now it doesn't matter what letter they have here. It doesn't have to be an x, especially with circles you'll see a y. So just do this exactly how you did it before, but instead of x's you're using a y. I think we're ready to move on to factoring and solving. So there's a difference between factoring and solving. To solve something, you actually have to factor it. Or at least in this case, you're going to have to factor it with these problems. When you solve, you're going to have an equal sign. When you're just factoring, there's no equal sign, okay? So you can see I have equals 0 here, and that's when I can solve something. That means I can find the x. But if I don't have an equal sign, there's no way to solve. Okay, so let's factor this. So that's my first step. Let's factor it. So what it means to factor is I'm looking for some x minus a number or plus a number. In fact, let's put plus. X plus b, so that when I multiply these two together, I get this answer. So exactly what we had here before. You see how we had this y squared plus 10y plus 25, and that was equal to this y plus 5 squared, or this right here. And in these previous problems, I want a better example. So let me move up a little bit, like this one here. Now you can have something other than a coefficient of 1 here. I think an even better example is this one. You see how I have something like this? What I'm actually trying to do is go backwards, go back to this. So what we've done is I gave you these two binomials and you multiply them together to get this. When I ask you to factor something, you take this and go backwards. So this is a little bit more complicated, but we can do it. So let's scroll back to our problem. Now the problems I'm going to show you in this video will always have a coefficient of 1 in the front, or if it doesn't have a coefficient of 1, we're going to pull out the greatest common factor and get it to a coefficient of 1. So that's what I'm going to show you here. Okay, so let's factor this. This is how you factor. You're going to draw an x. And you're going to put this number here, this -2, you see this -2? put it at the bottom of the box. And then put this -8 at the top of, well, you can call this a box or an X. What you're going to do is you're going to try to think of two numbers that multiply to give you this -8. So you want them to multiply to give you this, and you want these two numbers to add to give you this number. So in order for two numbers to multiply to give you a negative number, one of them has to be negative, right? So you have two numbers. For them to multiply to give you negative, one has to be negative, one has to be positive. So let's put the negative one over here and the positive here. So let's think about how we can break up 8. 8 is the same thing as 4 times 2, and 4 is 2 times 2. Okay, these are all the factors of 8. Now notice if I took a -4 and a +2, multiply those together, I get a -8. And if I add these two numbers together, I'll get a -2. So those are the numbers I'm looking for. This -4 and this +2. We're done with this problem, because now what we have to do is we say that this is equal to x minus this number and x plus this number. That's it. So we found the factored form of this. And you can double check it. You can FOIL this out. You'll get an x squared, which is right here. You'll get a 2x and a -4x, which will make a -2x. And a -4 times 2 will give you this -8. Let's try another one. Oh, and before we go any further, actually we want to solve something. So here we factored this. Now I'm asking you to solve it. So I want to find the x that when you plug in an x value into this equation here, you're going to get 0. Well, this factors into x minus 4 times x plus 2. Now, if you have two numbers, let's say you have the number a and the number b, and you multiply to give you 0. There's a rule with real numbers that says if two numbers multiply to give you 0, at least one of them has to be 0, right? If you do like 1 times 3, that's 3. That's not going to be equal to 0. Any number here or any number here that's not 0, when you multiply them, you always get something that's not 0. The only way for you to get a 0 number is if at least one of them is 0. So if a is 0 or b is 0. So here I have a number times another number. And this is a and this is b. And when I multiply them together, I get 0, which tells me a has to be 0 or b has to be 0. So we solve for x, and we get that x is 4 or x is -2. I just added 4 to both sides, and I subtracted 2 from both sides. So that's solving for x. And you can double check this. Plug in 4, you'll get 16 minus 8 minus 8. Well, that is 0. And the other number that works is if you plug in -2. If you plug in -2, you'll get 4 plus 4, which is 8, and 8 minus 8 is 0. Okay, let's try a different problem. So here I want to factor x squared minus 10x plus 21. And then after I factor it, I want to solve x squared minus 10x plus 21 is 0. So we're going to start with the factoring piece first, because we're going to need it for the solving piece. Again, what I'm going to do is I'm going to draw an x. I'm going to put, now remember before, I took this number, this -2, and I put it at the bottom, and I took this -8 and I put it at the top. That's what I'm going to do here. So -10, I'm going to put it at the bottom, and this +21 goes at the top. Now what you want to ask yourself is, what two numbers can I multiply to give me a +21 and add to give me a -10? Right, well, we want them to multiply to give us 21. So let's factor 21. That's 7 times 3. And notice that 7 plus 3 is 10, but it's not a -10. So how do I make it negative? Well, if I take a negative 7 and multiply it by a negative 3, negative times a negative is positive. So I do get 21. And if I add these two together, I get negative 10. So that tells me that this expression, factors into x minus 7, x minus 3. I just take an x and I subtract the first one. Well, I add this one, which becomes a subtraction sign here, negative 7, and then x plus this negative 3, which is x minus 3. I'm going to go back up just to show you what happens if we have a positive one. Remember, here we had a negative 4, so I put a minus 4, and here I have a plus 2, and that became a plus 2. Okay? So this is factored. And this box method I'm telling you will work for any trinomial like this, where I have 3 pieces, and the number in front of the x squared is a 1. If the number is not a 1, what you're going to have to do, let's say it was the number 2 here, you're going to put 2 times this last one up here, and then do the same thing. Okay, now let's solve x squared minus 10x plus 21. Well, remember that this factors into x minus 7 and x minus 3. So this is the same thing as x minus 7 times x minus 3 is equal to 0, which tells me x minus 7 is 0, or x minus 3 is 0. So x is 7, or x is 3. And we've solved for x. And again, of course, you can double check this by plugging them in. All right. Here I have a binomial, so I have 2 pieces, and I want to factor it. So let's factor x cubed minus 7x. Now the method I showed you dealt with trinomials, which had 3 pieces. For this one, you want to see if you have something in common for both terms. Notice that both terms have an x. That means I can pull an x out. If I pull an x out, I get x squared minus 7. Because I have 1 of these and 3 of these. If I take 1 away, I'll be left with 2 and none over here. And you can always double check to see if you got the right answer by redistributing this. Because we learned what we need to do if we distribute. We add the exponents, which will give me x cubed. And then I just take a negative 7 times x. So this is factored. But I also have right here an x squared minus 7. This x squared minus 7, technically you can factor it again. Because notice that if I have x squared minus some number, let's say a squared, then this is going to be x minus a times x plus a. This is called the subtraction of squares, I believe it was called. The difference of squares. So you can look back in one of your textbooks, or in our textbook, and see the difference of squares formula, or you can Google it. And so remember, this is a review. So the difference of squares is this. So you could say that x squared minus 7 is x squared minus the square root of 7 squared, right? Because if you take a square root and you square it, you're going to get the 7 underneath. So technically you can factor this a little bit further. This is x times x minus the square root of 7 times x plus the square root of 7, using this formula for the difference of squares, where this number right here is a. And I'm just plugging that into this formula, as you can see. So now that this is completely factored. Let's solve x cubed minus 7x, and I'm going to plug in that factored form, which was x minus the square root of 7, and x plus the square root of 7 is equal to 0. I'm just substituting that in. This is what we have here. And so we set each piece equal to 0. So we have x is 0, x minus root 7 is 0, and x plus root 7 is 0. Move everything over. This one's already done. Move this one over, you get square root 7. So that's the second option. And this one is negative square root 7. That's your last option. So these three options, when you plug them in for x, will give you 0. Let's try another problem. Here I have x cubed plus 14x squared plus 49x. I want to factor this. And then after I factor it, I'm going to set it equal to 0 and try to solve. So I'm solving for x. So what do I need to do? I would always start with trying to take out greatest common factor. So you look at every single one of the terms and see if there's something in common that you can pull out of it. Notice that each one of these has an x. So I can factor out an x. This is equal to x times x squared plus 14x plus 49. Notice that if I send it back in, I'm going to get this right here. Now let's factor this piece. That's what I'm going to focus on. So I'm going to ignore this x. I'm going to do that process I had for a trinomial where the coefficient in the front was a 1. So I put this number at the bottom, 14, and this number, 49, at the top. And I look for two numbers that add to give me 14 and multiply to give me 49. What are they? Well, for this example, it's going to be a positive 7 and a positive 7. So this factors into x plus 7 times x plus 7. I've seen a lot of 7s recently. Okay, so now we can find the fully factored form. Don't forget about this x. This piece is just for this piece. But originally, this is not what we had. We had this times x. So let's write that out. X cubed plus 14x squared plus 49x. That's equal to x times x plus 7 times x plus 7. You could even write this as x times x plus 7 squared if you want to get fancy. Okay, now let's solve x cubed plus 14x squared plus 49x. Let's solve for x in this equation here. So all we have to do is put the factored form on the left, which means I set each one of these pieces equal to 0. I only need to write one of these because I'm just going to write the same thing, so I'm going to get the same answer. I get x is 0 or x is negative 7. Those are my two options. All right, let's see what else we have here. Let's solve and factor x squared minus 25. Again, this is a binomial, so you want to see if you have squares here. We're going to use the difference of squares formula, which says if I have x squared minus a number squared, this is x minus that number times x plus that number. Notice that this is x squared minus 5 squared. Because 25 is the same thing as 5 squared. So then this is x minus 5 times x plus 5. This is the factored form. To solve x squared minus 25, we put the factored form here. It doesn't matter the order you write these. Set each piece equal to 0. And you get x is 5 and x is negative 5. I also want to mention that to solve this, another way to do this is just move 25 to the other side and then take the square root. But when you take the square root, you get a positive and a negative. So you get x is equal to plus or minus 5, which is exactly what I have here. Let me just double check. I think this is the last problem. Yep, it looks like it. So one more problem to go. Let's factor x cubed plus 36x, and then let's solve x cubed plus 36x. Okay, first thing you want to do is see if you have a greatest common factor. Can I pull something out? The answer is yes. I can take out this x. And now you want to see if you can factor this. If you have a sum of squares, not a difference, but a sum, you cannot factor it. This is as far as you can go. Okay, so the answer is x times x squared plus 36. That's the factored form. Now, if I had given you x cubed minus 36x, then this would be x times x squared minus 36. And now you have a subtraction sign where you can use the difference of squares. So this is x minus 6, x plus 6, because 36 is 6 squared. Okay? So to solve this, we put our factored form, and then we set the pieces equal to 0. We get x is 0, and if we try to move this 36 to the other side, we're not going to be able to solve this because you can't square a number and get a negative 36. So this is the only solution.